This video is part 2 of 5 parts, introducing trigonometry, junior high school trigonometry, right angle triangle trigonometry. This part 2 of the video looks at choosing which ratio or rule is appropriate for the question that you're doing. So, last video we learnt that right angle triangles are what we use in trigonometry. We learned how to label the right angle triangle. If you haven't seen part 1 of the video, watch that first. Now, this video is about choosing the rule. There are 3 rules in trigonometry that you need to know for junior high school and into senior high school. There are more trig rules, but we don't cover them in high school very much. The rules are just a shortcut to say which sides of the right angle triangle we are comparing. Now you remember with the labelling of the right angle triangle, we labelled the sides opposite, adjacent and hypotenuse, and they were all to do with the angle that was marked in the triangle. Now, if we're looking at a ratio of the opposite and the hypotenuse side of a right angle triangle, then that means we're using the sine ratio. And if we're looking at a relationship between the adjacent and the hypotenuse side, we are looking at the cosine ratio. And if we're looking at the opposite and the adjacent, we're looking at the tan ratio. Let me just flick forward to a triangle. So say we have a question where we want to find the height of something and we don't particularly want to climb it. Imagine this is a flagpole or something, or a big tree. Impossible to climb it to find the height of it. We can, if we know this angle down here and how far we need to stand away from the tree or the flagpole to get this angle here, we can, using the tan ratio, which compares opposite and adjacent, we can find the height of this flagpole that's too hard to climb. That's the kind of questions that you'll be using. So all of these rules that we're learning today are all ratios. Ratios meaning fractions. So the full names for each of these rules are sine, S-I-N-E, cosine, and tangent. But if you look at your calculator and the way we speak about them as well, you'll see that they're all abbreviated to 3-letter abbreviations. Now, the 3-letter abbreviation for each of them is just the first 3 letters of their name. So the first 3 letters of sine is sin. But we don't call it sin. We don't say sin, we say sine, even though the 3 letters do spell sin. The first 3 letters of cosine are cos. And depending on what country or what school you went to or what teacher you had, some teachers call it cos because it's short for cosine. But I call it cos, I must admit. And the first 3 letters of tangent are tan. So you often hear people talking about sine, cos, and tan. Those are the 3 rules. It is essential that you know which rules compare which sides of the right angle triangle. It's essential that you know that the sine ratio is a relationship between the opposite and the hypotenuse sides. It's essential that you know the cosine is adjacent over hypotenuse, and it's essential that you know that tan is opposite over adjacent. And so mathematicians, maths teachers over the years have come up with all sorts of weird and wonderful ways to help us, to help you, remember which ratios go with which sides. This is the first one. If you use the first letter of each of these, so S for sine, O for op, H for hypotenuse, so S-O-H, C-A-H-T-O-A, you make a sort of odd word. And I say it in sort of an odd way. I say this word as Sokotoa. Sokotoa. It's probably very politically incorrect and probably a wee bit racist, actually. It reminds me of a brand of rice crackers. But Sokotoa, if that's a way to help you remember it, then that's fine. Most people remember a little rhyme or a acronym to help them remember. And this is also very politically incorrect. Some old hags, see the S and the O and the H just from the Sokotoa and the rule, some old hags, hams if you like, can't always hide their old age. It's not the only one. I googled, It's a whole lot of these ones. All of them are somewhat incorrect, politically incorrect. Whatever way works for you, use it. But you have to know, you have to have it at your fingertips. You have to know what each of them stands for. So if I say sine, you should straight away be able to tell me opposite over hypotenuse. If I say tan, it's opposite over adjacent. So let's have a little practice. Here is a naked right angle triangle. So first thing I'm going to do is I'm going to put some information on this right angle triangle. I'm going to put an angle. Oh, actually, no, I'm going to put an X. I'm going to put an angle. I'm just putting these things any old place to tell the truth. And I'm going to put a side. Now, the trick is that you have to have 3 pieces of information. Other than your right angle, which is standard, you have to have 3 pieces of information, 2 of which you know and 1 of which you don't know. Then I must admit at this point I like to put circles around the, well, no, I tell a lie. Hold the phone. First of all, your first step, first video said you've got to label the triangle. So let's label this triangle now that we've put some information on it. First of all, opposite the right angle, making a little arrow out of the right angle, that's your hypotenuse. So over here is H, and then sitting on this corner of the triangular room, this is the side that's adjacent, and over here is opposite. Now I go and I circle the information that I have. I've got some information about the hypotenuse, and I've got some information about the adjacent. And as soon as I see the A and the H, I go back to my rules and I say which one uses A and H. Aha! This is a cosine question because A and H are the 2 sides that I have information about. Let's undress this right angle triangle and do another one. Oops. Okay, so let's use a theta this time, and let's use this number here and this number here. Now let's move that one over. Okay, first step, label the triangle. There's the hypotenuse. It hasn't moved. It doesn't really care what angle's what. So that's the hypotenuse. And then we've got the opposite side over here, and the adjacent side is next to it. We're going to put circles around the sides that have information on them. Now, I'm not putting a circle around this side because I put that A there. There was nothing there before I put the A there. So, O and H. Go back to my rules. O and H. So that I would need to use a sine ratio to solve that problem. Here we go. Here's 3 triangles. I've been really kind to you. I've made one of each. I would like you to pause the video and have a go at seeing if you can identify which ratio goes with which triangle. Pause the video. Okay, how did you go? Let's do some circles. This triangle, where are my circles? They're not circles really, they're oblongs. Oh, no, I can't do that first. I've got to label first. Labeling, my goodness, how could I remember? The first step is labeling. I'm going to be using squiggly writing, so you're going to have to forgive me. So, a right angle, just change the colour of my pen. Right angle points to the hypotenuse. There's my hypotenuse, and so the other side that's next to the angle must be the adjacent, and this side over here must be the opposite. Let's get my shape out, my oval. This side has got information on it, this side has got information on it, bad circles there, and this side doesn't have any information on it other than the red writing that I did. So this rule is using A and O. Some old hags can't always hide their old age. That's tan one. Tan. Did you say tan? Well done. Good work. Let's have a look at this one. Oh, wrong tool there. Let's get rid of that. Get my red pen again. Here we go. Arrow points to the hypotenuse. And the side that's next to the angle is the adjacent, and this other one with the tennis ball, is the opposite. Let's put some circles. Okay, so the information that I have is about the adjacent side and the hypotenuse. Car, that's a cos question. There. Now we know this is going to be a sine question, but let's go through the motions anyway. Here is my right angle pointing to my hypotenuse. This other side is next to my angle, and this one must be the opposite. Get my circles, really bad circles. So O and H, S-O-H, sock, some old hags. It's a sine question, as we expected. I hope that's helped you identify rules. Watch part 3 of the video where we actually start solving some problems.